Here's the second of two lessons on Bohr-Rutherford diagrams. So if you haven't watched the other video first, you probably want to watch that one before watching this second one, because you probably won't understand half of what we're going to be talking about. So this lesson is on something called an ion. So before we get there, let's just make sure we understand that atoms are neutral in their charge and why they're neutral. So here what I have for you is a Bohr-Rutherford diagram of a nitrogen atom. And I can tell that nitrogen, this is a neutral nitrogen atom, because when I look at the nucleus, I can see that there are 7 protons. So what does that mean? Well, it means that I have 7 positive charges. And when I look at the number of electrons here, I see that I have 1, 2, 3, 4, 5, 6, 7. And I have 7 electrons. So if I have 7 positive charges and 7 negative charges, then the sum total of the charges is 0, and that is really what makes this a neutral atom. But the thing is that even though nitrogen is neutral, it's not 100% stable or happy. And the reason for that is that all atoms will strive to try and complete their outer shell. So when I look at nitrogen, I can see that nitrogen has 5 electrons in its outer shell. And so it has a couple of options here. So nitrogen could go about becoming stable or happy by either, it could lose 5, right? So it could lose electrons, and in fact it would need to lose 5, and by doing that, then what you would see is that it would only have that inner shell, which is full because it has 2 electrons in it. The other thing that could also happen is that it could gain, I'm just going to write G here, well, gain 3 electrons. And so really these are the 2 options for nitrogen. And so what do you think? What do you think would be easier for nitrogen to do? Well, in class when we discussed this, most students thought that gaining 3 would take more energy than losing 5. And they were right. In most cases, nitrogen would want to gain 3 electrons. And so that brings us to the topic of charged atoms, because of course if we see nitrogen, which was perfectly neutral, gaining some negative charges, then that's going to create a situation where it's no longer neutral, and that is the topic today. So this is the point in the lesson where students will often ask me, well, what about the protons? Why can't they gain or lose protons? Well, remember that when we were talking about the structure of an atom, we talked about how the protons were kind of like the element's DNA, right? So the protons define what element it is. So we can't have the protons leaving or we can't add any protons. And the reason for that is because by doing that, we actually change what element it is. But moving the electrons around, either having them gained or lost, we still keep the same element. So just remember that. Protons never leave, never get added. Only the electrons can be added or taken away from an atom. So remember that thing at the beginning that when we added a few electrons to nitrogen, well, that thing, that charged particle, has a special name in science. We call it an ion. So an ion is that particle that gets formed when that atom gains or loses 1 or more electrons. So essentially, what is an ion? An ion is an atom with a charge to it. It's no longer neutral. And that happens because the number of electrons is no longer equal to the number of protons. So there are really 2 things that can happen to an atom with respect to electrons. As we saw earlier, an atom can lose electrons or it can gain electrons, all in the hopes of getting that full outer shell. So let's take a look at an example using the lithium atom. And I can tell that this is a lithium atom because I can see that it has 3 protons. And so if I flip to my periodic table, I'll see that lithium has an atomic number of 3, and so therefore the 3 protons are telling me that it's a lithium atom. So I'm just going to write lithium atom here. Now, if it's a neutral atom, then it has 3 protons, and it should also have 3 electrons, and that's how I've written it. Remember, 2 electrons in the first shell, and then the 1 extra will go in the outer shell. Now lithium's not super happy in this situation because, and it really wants to get rid of that 1 electron in order to become stable. So what's going to happen is it's going to actually lose it. And when it loses it, then it has lost that second shell or second energy level entirely. So whereas before it would have had 3 positive charges and 3 negative charges, now it no longer has that balance, giving it a neutral charge, right? So now the case is that I have my 3 positive charges coming from the protons, but I only have 2 electrons balancing out those charges. Right? So what happens here is that I end up with a surplus of protons, and that gives this particular ion a charge of positive 1. How I symbolize that is as Li, and I put the little plus 1 as sort of like a superscript just to the side. And that tells the reader that this is not a lithium atom, it's a lithium ion with a positive charge. So there's a special name that we give to an ion that has a positive charge. A positively charged ion is called a cat ion. So it may help you to remember by thinking about cats, you know, cat ion, positive. So of course the second thing that can happen is that an atom can gain electrons, and certain atoms will want to do that. So for example, I take a look at the fluorine atom, and the fluorine atom has 9 protons. So that's how I can tell that this is a fluorine atom, because it's 9 protons and 9 electrons, and that makes it neutral. So my fluorine atom, when I look at it right now, it has 9 positive charges because of those protons, and it also has 9 electrons, and that makes it neutral overall, right? A balance of electrons and protons. So this is my lithium atom. Okay, so I would symbolize that with just the straight up, fluorine rather. Fluorine straight up with the 9 protons and electrons. Now, so let's examine this really closely. So unlike lithium that had 1 extra electron, it looks like fluorine has 7, so it's much closer to having that full outer shell, which will make it very, very stable. And so it's much easier for fluorine to be able to grab onto an electron in order to reach that stable configuration than it is for it to lose 7. That would take a lot more work. So that's in fact what fluorine does. So let's look at the charges and how that works out. So we didn't mess around with those protons. They are going to stay in the nucleus. But now I've added this extra electron in. So I no longer have those 9 electrons. I have an extra one. I have 10. So when I look at the balance of the charges, it looks like I have a surplus of 1 electron. And that gives this particular atom a -1 charge. So in fact now it is a fluorine ion. It is no longer called an atom, and we would indicate that to the reader by putting a negative, or sometimes you'll see a -1 there. So that's the gist of how it is that you would adapt a Bohr-Rutherford diagram in order to account for the fact that it's an ion instead of an atom, right? So if it has a negative charge, that means that I've added in electrons, right? But if it's a positively charged ion, then that means that I must have taken away some of the negative charges. So one of the last things we need to do is we need to know what the name is for these negatively charged ions, right? So if the atom becomes negatively charged, then it has a special name, and that special name is an anion. So cations are positively charged, and anions are negatively charged. So I want to go through a couple of examples with you to further explain how to draw the Bohr-Rutherford diagram for particular ions. You may feel ready to start the worksheet, and if you are, then that's great. Go ahead and do that. But some of you may feel like you need some extra clarification through some examples. So let me go ahead and do that. So I'm going to start with aluminum. And so in this case, I can see that there's a 3+ there, and so that tells me that this is not a neutral atom, this is a cation. So the way that I would go about this would be to take a look at the number of protons, neutrons, and electrons that would normally be there in a neutral aluminum atom. So by looking at the periodic table, I can see that aluminum has an atomic number of 13, and so that tells me that as an atom, it would normally have 13 protons in its nucleus, and 13 electrons. This is if it's neutral, right? But it's not neutral, and that's the problem here. I have an ion. And so because aluminum has a 3 positive charge, that means that I have 3 extra protons compared to electrons. And so remember, I can't mess around with those protons. So the only way that I can come up with an overall positively charged ion is to reduce the number of negative charges. And by how many? Exactly 3. So instead, I would see aluminum having 10 electrons instead, because 13 positives and 10 negatives gives me an overall charge of positive 3. And so from there, I would go ahead and I would draw my Bohr-Rutherford diagram once I'd figured out the number of neutrons. To save time right now, what I'm going to do is just write those in. I know my mass number for aluminum is 27, and I know that the atomic number was 13, and so the number of neutrons that I have are 14. And so I know it's a little messy, but I've got 13 protons in my nucleus and 14 neutrons, and now I'm going to start to populate this Bohr-Rutherford diagram with electrons. So I'm going to put 2 in the first orbit. That's how many I can fit. So I've used up 2 of the 10, and that gives me 8 left. And so I'm going to put them all around the world, north, south, east, west. And when in doing this, I can see that this makes sense for this ion because it has this full outer shell with 8 electrons in it. Now I'm going to go, and what I'd like you to do is I'd like you to try to do O2 negative for yourself and then check the answer. Hopefully you've tried this on your own. So just to speed things up a bit, what I've done is I've written out for the neutral atom the fact that oxygen would have 8 protons and electrons and 8 neutrons. But this negative charge right here tells me that I've added in 2 extra electrons. So in fact, this atom would not, or this ion rather, would not have 8 electrons. It would have 10. And so I still have 8 protons and 8 neutrons in the nucleus, but I need to populate these energy levels with 10 electrons because it has an overall 2 negative charge. So I'm going to go ahead and do that. 1, 2, and then the other 8 in this outer shell. And this is a reasonable answer because, again, these ions form because the atom is looking to become more stable by filling its outer energy level. And that's it. If you have any questions, make sure to come and see me in the morning or at lunch, or even after school on Monday before your quiz. Good luck.